I do believe that we are live. Signs indicate that we are live. So, as per the title of this video, I'd like to submit the revised timeline for when the sun will send civilization back to the Stone Age. I know it's an important topic for many of you viewers out there. You're very concerned about when the sun will send civilization back to the Stone Age. And hey, I don't blame you. If civilization's going back to the Stone Age, you should certainly know ahead of time, right? So anyway, here's the revised timeline for when civilization will go back to the Stone Age because of the sun. Never. That's the timeline. Never. Civilization's not going back to the Stone Age because of something the sun does. It might damage some satellites. It might damage some power grids. It might put out your power for even for an extended period of time. Who knows? Maybe even more than a day. But if you live in a first world nation, you'll probably be fine. Uh, yeah, the sun. It's never sending Earth back to the Stone Age. So I figured I'd cover that right away since it's such a common thing that we hear constantly in the space weather community, which is barely a community. I mean, nobody really does coherent daily space weather content besides our channel in the first place. So there's that. So we'll briefly tell you what's going on with space weather, like what the sun's been up to, the likelihood of large flares, if there are any incoming coronal mass ejections, etc., as we're known to do on the channel. So let's get into that. Now that we're where we're supposed to be here at our anti-dentite SNN Central Studio. Pardon the ad hoc creation of this video, but these live streams seem to do much better when they're in portrait mode. I guess because most people view on a mobile device. So, in any case, it's whatever. We could, of course, do an extremely high quality live stream with screen share, but instead we're going to use this guerrilla technique because that's what YouTube seems to be telling us to do. So, let us know what your thoughts are on that in the comments, as we're always interested in what viewers think about some stuff. By the way, if you didn't know, we've started a band. So there's a three-piece that's been created. It's I, and it's sort of my brainchild, but it also includes Forrest McKinnon and Jason Williams. If you don't know who they are, you're about to find out. Because we've already got some songs that are largely completed with a lot more original music to come. So, yeah, a little teaser for you there, YouTube viewers. I even made a graphic earlier today. Here's a sneak peek. Run, D, F, J, fa, for you, fresh. New tracks. So yeah, let's see what's up with the sun here. We'll show you the ionosphere and everything, and we'll tell you if GPS errors are likely and all of that good stuff. Like we said yesterday, cosmic ray flux is down to levels not seen since the 1990s, or it's very close to those levels. So, but we're certainly in the lowest cosmic ray flux we've had since the early 2000s, since 2004. So we're consistently at that level. It's looking like solar cycle 25 is probably a stronger cycle than solar cycle 23. It's yet to be determined. We're still only about a year out from solar maximum. So on the ramp down here, here's the OLU neutron monitor. And as you can see right here, we have seen levels that are lower than the 2004 levels. So we did see levels get way down here to where they were back in the early 1990s. If you think energy from space is increasing somehow, well, I'd like to know how, because cosmic ray flux is at a very low level. Very low level. Do we have any new CMEs? Well, it doesn't look like it. At least not earthly directed ones. There's the Huxt forecast animation from University Reading. Sunspot number is at only about 60 sunspots right now, 60 sunspots. We haven't had any major activity, I don't think, from that active region in the southwest. Radio flux, the 10.7 centimeter radio flux, is at 120 solar flux units. As far as NOAA's forecasting goes, NOAA's not forecasting any significant space weather. There it is. So calm conditions are expected moving forward in the next few days. Current solar wind around noontime universal time today on November 19th. Total field is 8 nanotesla with a BZ of +6. Solar wind density about 1.4 protons per cubic centimeter. Solar wind velocity here very nominal, very average, very uninteresting at 403 kilometers per second. Proton flux is flatline, no SEPs or solar energetic particle events. We had a flare that was almost an M-class event. Let's see if we can see where that's coming from, although I'm sure it's pretty obvious. Did it come from behind the limb? All right, we'll get back to that in just a minute. Next, we'll look at CMEs here. Here is the LASCO C2 for you. There could be some Earth-directed ejecta there, hoping that there is, but doubting it. And if so, it's very minor, very minor. So we'll look at stereo A just to sort of verify that. Stereo A's Core 2 space weather beacon. And it looks like there's a little missing data there. Do we have the current? So here are the last few hours. So no new earthly directed CMEs there. These are all on the far side or toward the solar limb. Next, Earth should be in a North Pole oriented magnetic sector now. Let's see if we've crossed the current sheets. Just about to enter the north magnetic sector. So we do have North Pole oriented coronal holes rotating in. You can see we're only a few hours away from crossing in from a South Pole magnetic sector, shown here in red, to a North Pole one, shown in green. That is largely because of coronal holes, which show us the solar sunspot cycle. In another way, the magnetic portion of the sunspot cycle, where the solar polar fields migrate from one pole to the other throughout the cycle. Here's our line of sight coronal hole plot, and you can see North Pole oriented coronal holes rotating in here. And we do have a comment there. I'll get to your comment, Stratotanker 837, in a moment. There are our Boulder magnetometers. You can see some minor perturbations happening there in both the H and D components, but nothing major. There is no space weather that is major happening at the moment. Let's take a look at Cerro Tololo's magnetogram and see what this sunspot on the Earth side of the disk is doing. We're talking about this one right here. And it's been largely stable. We're going to actually go to Lermonth here, even though the data is a little bit older. It'll be more contiguous here at the end. Yeah, pretty stable there. No major changes. So we'll look at L-Tide here for the intensity gram. That's actually 677 nanometer wavelength, but similar to visible light. So yeah, that group is still interesting. We do have a new sunspot that's formed down here. So far, it's only an alpha class sunspot, as I only see one umbra. We also do have a sunspot over here, so it looks like sunspot number is going to go up. Another one rose here. So yeah, a little bit of an increase in the sunspot number can be expected today. And as far as your comment here, Strato Tanker 837. Yeah, you're welcome. I mean, the grid, listen, the grid is fortified enough that civilization's not going to end, even if there's a major solar flare. Major solar flare, major coronal mass ejection, major solar storm impact on Earth. It's not going to shut everything down, guys. It just isn't. You know, military installations, vehicles, communications networks are already shielded against electromagnetic pulses. Many of your communications towers are double diesel generator backed up. So the grid is a lot more fortified than you may think it is, especially in first world nations. And not only that, your transformers out on the poles, they all have circuitry that senses the induction and shuts down the transformers before they burn up. So the likelihood of the grid ever going down, like on the whole planet for an extended period of time, is just about 0%. If you don't agree with me, ask Tamitha Scove, ask Scott McIntosh, ask people that know a lot more than me about space weather and about physics, because, like, facts. Moving right along, and thanks for leaving a comment, Strato Tanker. We do appreciate that. And anybody who has a question, feel free to ask it, because, alas, ignorance is the root of all knowledge, folks. You have to not know a thing before you know a thing. Right? Here's our filaments, our L-Tide Hydrogen Alpha Telescope from the National Sunspot Observatory. Fortunately, still functioning throughout the government shutdown. The record-breaking 43-day-long government shutdown. So there you see a bunch of filaments. There is certainly potential for Earth-directed coronal mass ejections. Remember, folks, you don't need to have sunspots or flares to have coronal mass ejections. We see CMEs constantly happening, even around solar minimum. We even figured out how to forecast coronal mass ejections sometimes on the channel. So, facts. Don't get solar flares and coronal mass ejections confused. They are separate phenomena. Coronal mass ejections are protons. Solar flares are photons in the form of X-ray emissions. Electron flux here, pushing storm levels once again. So your GPS will have pretty bad performance the closer to the equator you are and the closer to 12 noon you are. You'll have a puffy ionosphere above your head with a lot of ions in it. So here's an animation of that. That's just the last 6 hours. Let's bring up the previous day here. So there's the previous day of the ionosphere. And yeah, the South Atlantic anomaly remains out here in the Pacific Ocean, right near the equator, as opposed to over the South American continent. You can see that's right about here. So that's the F layer of the ionosphere in vibrational frequency, megahertz, millions of vibrations per second. Highest frequency zones are up to 14 megahertz at the moment. We'll show you the anomalygram as well. We're going to show anomaly in megahertz from a 30-day median. Now, I would also note that there is an African anomaly right here, also right on the equator there. So right on the west coast, the west coast of Australia, right on the equator. There is a smaller anomaly there. You can see it right where my pointer is. But the biggest anomaly in the ionosphere is this one, the South Atlantic anomaly, which is actually now the Central Eastern Pacific anomaly, because it's over the Pacific. So that's where it is. If that spooks you, read them and weep. Here are the last couple of hours from the closest star. The best one to gaze at if you're a stargazer. If you're an astronomer, cosmologist, etc., you should know a lot about this star before you know jack about any other ones. Anyway, it's time to close this out. Thanks for tuning in, everybody who has. Congratulations on realizing the channel exists. Don't forget to press the things like share, as videos are often not seen. It's like we're rolling dice when we make a video on this channel. We never know if we'll have 3,000 views on a live stream or 35 views on a live stream. So anyway, Earth not going back to the Stone Age ever. So deal with it. There are deep underground bunkers and all kinds of dumb things. And it's just ridiculous to have all this fear about stuff that isn't scary. So if you're scared of the sun, you're scared of the galaxy, you're scared of the planets, you're scared of the moon, you're scared of clouds, like get real, folks. Get real. It's just ridiculous. Anyway, we'll close out with the ionized helium spectra. Ionized helium here as observed by the GOES 19 SUVI. It's splentacular, just like you, the viewer. Hopefully you'll have a splentacular day. We'll talk to you soon here at the Smash News Network, least busted name in news. And until next time, I've been your host, Dan, a.k.a. Smash-O-Mash. And may that solar wind be at your back.